Hello, everyone. My name is Murray Tom. I'm the Vice President of Software and Cloud Services at D-Wave Systems. I started with D-Wave a little less than 18 years ago, building quantum computers with the technical teams, and then going out in the field and talking with our customers about what kind of quantum problems that quantum computers solve. And now I'm the product owner for D-Wave's lead quantum cloud services offering. I'd like to thank the organizers of NEC's iEXPO for having me here today, and I'd like to thank you all for taking the time to listen. I'm really excited to share what I know about quantum computing and hopefully to interest you in applications for quantum hybrid technologies for business. This is an interesting forum. I'm very sorry that I can't be there to present with all of you and be there in person. And I hope that everything goes smoothly. But having done a few practice presentations on my laptop, I know that it is a little apparent that I am both the presenter and my own audio-visual controller. So I'll do my very best to make a great presentation. Let me share my screen with you all. Full screen mode. All right, let's begin. I want to first start by saying that D-Wave is focused on practical quantum computing. Our mission is to unlock the power of quantum computing for the real world today. So I am hoping to share with you information, help familiarize and take away some of the complexity and mystery of quantum computing and demonstrate to you how it can be used in applications for business right now. To share just a few of the examples of organizations who are using quantum computing and developing applications that they're building and deploying. And then to also share with you some of the new technology that's upcoming and interest you in what's around the corner with quantum computing technology. D-Wave Systems is a world leader in commercializing quantum computing systems. We've been doing it for more than 20 years. And the model of quantum computers that D-Wave are building are quantum annealing machines. The interesting thing about quantum annealers is that the origins of the idea of quantum annealing came out of some talented work at Tokyo Tech in Japan. It was the researchers Nishimori-san and Kadawaki-san and their talented work that involved suggesting the use of quantum technologies to accelerate optimization problems and finding the solutions to them that are relevant to business. And at D-Wave, we're really excited that we've actually been able to realize that idea in a technological form that people have been using around the world today to explore as many as 200 early applications. We're really excited to have formed a joint collaboration with NEC to further the adoption of quantum computing in the Japanese market. What's great about our work together is that NEC is a proven pioneer in world-changing technologies, and together, D-Wave and NEC bring together a lot of complementary skills. NEC has formed a quantum computing office to investigate and explore and bring about new advanced quantum applications to the market. And they have even built with their vector engine technology the ability for businesses to begin to explore problem forms suitable for quantum computers. How we're going to do this is through bringing together quantum technologies and classical computers so that they each bring their strengths to benefit the applications that would be built. And this hybrid quantum classical approach is the one that D-Wave and NEC will be using in combining our efforts to bring quantum benefit to businesses that want to run quantum applications today and in the future. With that, let me talk a little bit about quantum annealing itself. So there's so much about classical computers that we're familiar with, the technology, the university programs, and there's so much that we take for granted when we think about computing, which has changed with quantum annealing and quantum computers. Let me talk a little bit about when a programmer is forming a problem for a quantum computer. The quantum computer sees that as a landscape. So the programmer is giving an indication of a problem that they would like to solve. Where are the penalties? Where are the things they would like to avoid? And where are the incentives? And the quantum computer sees that as peaks and valleys in a landscape. So it is trying to avoid the mountain peaks and find its way down to the deepest valley or valleys in the landscape. Classical computers can be used to approach problems like this. And they do that by stepping through the landscape one point after the other in order to make their way through it. They follow downhill paths in order to find their way into low valleys. And it requires a fair bit of energy and time. The reason for this is because even small problems can be defined with spaces of solutions that are larger than the estimated number of particles in the universe. So even if a classical computer could search routinely through 5 billion solutions every second, that is still a very small neighborhood of the whole solution space that's involved in obtaining the best solutions for the problem. Quantum annealing is radically different in its approach. Think about it as though the quantum annealer is exploring the landscape by raining down tiny droplets all over the landscape of water. These droplets then flow off of these mountain peaks and they begin to make their way down into valley bottoms. But even more so, they can actually tunnel through barriers to make their way from some valleys down to deeper valleys in the landscape. And with quantum annealing technology, they can use entanglement and superposition to accelerate that discovery of the deeper valleys. They can do this in a faster way and in a much more energy efficient way based on the way that quantum computers have been built. The systems are programmable with Python, with familiar software development kits. There's no quantum expertise required, and large-scale systems are available in the cloud today that developers can begin programming with and experimenting with deploying their end-to-end quantum applications. So let's look a little bit at the history of quantum computing. In the past 20 years, quantum computing has been highly theoretical, and early systems have only been available to small groups of highly specialized members of the scientific community. 2 years ago, a group of researchers at Texas A&M and at NASA were able to demonstrate using a D-Wave system a 100 times speed up over an entire collection of state-of-the-art classical heuristics. 1 year after that, we were able to demonstrate experiments in Science and Nature that showed the simulation of novel quantum materials and finding phases of their behavior that are only possible to be realized with quantum states. In those demonstrations a year ago, as have been appeared on the archive, we've been able to demonstrate that it's 3 million times faster to do those computations with a quantum annealer than with state-of-the-art classical methods. So that's where we are today, building towards demonstrations of customer advantage, where users are building, as I said, these 200 early applications and experimenting with them, using them in their business to find their business advantage with this new technology in order to be able to harness that acceleration today and in the future. Quantum computers are, it might surprise you to find, are accessible today. In fact, your teams, your companies already have access to quantum computers on the internet. Developers can sign up for free in Japan, in the US and Canada, and in Europe, and they can get a free minute to begin exploring examples on how to program quantum annealers and hybrid solving technologies. And businesses around the world can actually run and build their applications in that service today. In fact, not at the time of this recording, but when you actually see this presentation, D-Wave, a little sneak peek, D-Wave will be expanding access to LEAP to include developers in India and in Australia as well. We're really excited to bring this technology to those markets at that time. One of the first examples I wanted to provide about quantum applications built using this technology has already been tested at a production scale and deployed in the world in real time. And that is a project that was done by Volkswagen, where they were optimizing the route of shuttle buses at the Web Summit in Lisbon. Passengers were getting on the buses, and Volkswagen was working with partner providers to provide routes to buses, and then tracking their routes, were actually sending off in real time optimizations to the quantum computers in Vancouver in order to be getting answers back and then rerouting the buses in the most optimal path based on the traffic in the city of Lisbon. So as much as, in my experience, it has been a very fun challenge to bring about quantum computing technology and realize it. It has actually now reached the point where it is ready for commercial production deployments in the world over the wire in real time, and that has brought about its own interesting challenges. Denso is a leading manufacturer of automotive parts, and they have a lot of facilities. They have begun experimental work to look at using quantum annealers to improve the efficiency of their factory floors. On those floors, they have autonomous guided vehicles that move around various spaces, and they have to coordinate and balance their ability to move quickly through the factory and also safely with no collisions. They looked at an optimization plan and reformulated it for the quantum annealer and found that they were actually able to improve the efficiency of the factory floor and the speed with which the AGVs could move around the factory by 15%, even when they were prioritizing safety over speed. Another set of early applications are those that have been done by Recruit Communications in Japan. Recruit is focused on making sure that in their marketing and their online presence, they get the right user at the right time with the right message. And they ran some experiments to develop brand recognition more efficiently through TV advertising, and using methods that combined machine learning and quantum optimization in order to be able to improve the efficiency of reaching the minimum effective frequency where users really recognized brand placement. They also went on to develop more efficient recommender systems through the web and in their online advertising, including changing the rank order of hotel recommendations that have been online. And we were really excited to see them report that they had seen a 1% uplift in their online services, the sales of their online services. A group at Toyota has used quantum annealers and expanded some of the work that's been previously done to look at changing the way that traffic control is handled within cities. And they made the observation that rather than trying to do local control of traffic, they modeled an entire city square grid and attempted to do a global optimization. And they were successfully able to use the quantum annealer for that and observe that they were able to find improved efficiencies over alternative approaches by considering this global optimization of these discrete choices that needed to be made in that traffic flow across the grid. Another example I'm excited to share with you is GrooveNuts in Japan. This company has an online platform called Magellan Blocks for helping businesses to actually build AI and quantum computing applications. And it makes it a simple way for people to be able to pull componentry together and create solutions for their business problem. An example application that they built was looking at making more sustainable cities, looking at waste collection applications between buildings, and optimizing the routes that they chose in order to make sure that to find a way to reduce CO2 emissions. And in so doing, they were able to demonstrate a 57% reduction in the distance that needed to be traveled, and as a result, the corresponding CO2 emissions needed to power that waste collection. And as much as a 59% reduction in the number of vehicles that would be needed in order to collect that waste. At D-Wave, we've been working with a company in the biology sector called Menton AI. Menton has been working with D-Wave's hybrid solution technology in order to be able to develop a business which takes protein design out of the wet lab and makes it a computational problem. So they will actually go through and study a protein for its properties and the type of binding properties or interaction properties that they would like it to have. Perhaps they would like to be able to change a treatment from being absorbed by injection to one that could be absorbed if it was taken orally or by a nasal spray. Or perhaps they'd be able to develop a new therapy or a virus binding protein. They have been able to take their state-of-the-art classical technologies that they use for this computational design of proteins and adapt an expensive computational step so that it can be passed to the hybrid solving technologies that D-Wave has created and optimize the design of the protein and actually suggest, in many cases, tens or hundreds of designs, which then they can go through and verify through protein folding simulations and experiments. They have observed that they've been able to obtain solutions 100 times faster using this hybrid technology than with the state-of-the-art approach that they were using initially. So they've already seen the business value in being able to use these optimizations. And for larger proteins that they're designing, in the design time that they have available, they've been able to obtain solutions that are better quality than they would have otherwise been able to, which accelerates their computational design process. It means that in the iterations of going through design, synthesis, testing and evaluation, verification, and then redesign, they're actually able to shorten those iterations so they can get through more design cycles and get more effective solutions in less time. Earlier this year, as the COVID-19 pandemic began to become something that we were all increasingly aware of and it began to affect all of our lives, D-Wave, working with many of its customers, made access through LEAP to its quantum computers and quantum computing products and technologies available for free to allow users to develop responses to the COVID-19 pandemic. And one of those customers who's been working very productively in that space is Sigma I. And whether it's examples of like transportation and logistics, optimizing the availability of resources between hospitals, making sure that the necessary equipment is in the right place, making sure that if there's an outbreak in a particular location, there are opportunities to get patients to the medical centers that they need to, or whether it's other examples, things that are pressing in these secondary phases of the pandemic associated with optimizing our interaction as we're trying to get businesses reopened and get the economies restarted, including the ordinary logistics and scheduling that we are all having to go through in order to make sure that we can keep in close communication with our colleagues as we're transitioning from office work to remote work and between. Now, in my experience, many times when we come to these events, when we come together to meet with each other, to ask questions, to learn about new technologies, it's not just to find out about work that has been happening, but what's really exciting about it is what's around the corner. What is coming next, and how can we prepare ourselves, prepare our teams and our workforces to be able to bring those on? I'm really excited to share with you that later this year, D-Wave is going to be launching its Advantage quantum computing system. It is the most connected programmable quantum computer that's ever been available to any of us. It will bring about more than twice as many qubits, 5,000 qubits, and greater than 5 times as many couplers at 35,000 couplers. This means that the processor technology itself is more highly interconnected, and that will allow the technology to produce higher quality solutions to users and to make it easier for businesses to map their applications into the technology to obtain those solutions. At D-Wave, we're not an integrator of other people's technologies. We have had to build a lot of novel technologies to make this technology a reality. And this will represent the most complicated superconducting circuit that has ever been fabricated and deployed commercially in the world. It will also bring about innovations in the form of lower noise fabrication, which are central to the ability of the technology to obtain high quality solutions and increase the relative performance advantage against any other computational resources we have available to us today. What's also great about the work that our teams have been doing at D-Wave as we've been working together on this program is making sure that we're solving the technical problems, not just at the quantum processor level, but across all of the software and systems necessary in order to be able to bring these to bear for quantum applications, including latency and integration into software tools and systems in LEAP and in Ocean. And we're really excited to be continuing that work in partnership with NEC in order to be able to develop more advanced technologies, higher quality services and systems that are going to be serving yourselves and other businesses and other organizations with their missions in the Japanese market and beyond. So how do we get started? Well, I hope that by sharing this small set of examples, these few examples, that is just the beginning of the 200 early applications that people have begun to investigate, and that D-Wave and NEC are now working on bringing and making available to customers in the Japanese market. It's also important, once we've identified the correct business problems to solve, to get started on building hybrid applications in Leap. Whether it's, if you're interested yourself, or if you have members of your team who are ready to get started, they know how to do Python programming and have optimization or machine learning or simulation problems they're interested in investigating, they can sign up for Leap today and get access to the systems. It includes free time available right away and a set of examples to get people started, to get up to productivity in as short a time as possible. As well as that, we would like to invite you, NEC and D-Wave would like to invite you to a quantum computing challenge that we're going to be holding later this year in 2020, where we want to bring resources to bear to accelerate programming and also to see what kind of exciting applications people can build when they come to an event like that. So with that, I would like to, again, thank the organizers of the NEC iEXPO for 2020 for inviting me to give this presentation to all of you. And I would like to thank all of you for taking the time to listen to this presentation and look through all of these examples. I hope that I have been able to share with you some of the excitement that I feel about quantum computing technology and the interesting ways in which it's being used and put into application. And I hope that you'll all have a great rest of your day. Thanks very much.
Orchestrating a brighter world, NEC.